All new energy vehicles, during high voltage power-up, must go through a pre-charge process. What happens if there is no pre-charge? Today, let's test it. To make it easier for everyone to see, I've built a test circuit. This circuit simulates the entire battery pack power-up process. It includes the main positive contactor, the main negative contactor, and the pre-charge contactor. This white component here is the pre-charge resistor. In the external circuit, I'm using a light bulb as the load, and here we have a capacitor, used for voltage stabilization and filtering. Next, we'll use this circuit to simulate a normal battery pack power-up. First, connect the power supply. We're using 220 volts DC to simulate the battery pack output. Let's connect the positive and negative terminals. Alright, power on. Now 220 volts is being delivered normally. During normal vehicle power-up, the first step is closing the main negative contactor. The second step is closing the pre-charge contactor. The third step is closing the main positive contactor. The fourth step is opening the pre-charge contactor. At this point, high voltage power-up is completed. Now let's see what happens if the vehicle skips pre-charge and directly closes the main contactors. Let's simulate it. First, close the main negative contactor. Then close the main positive contactor. At the moment it closes, you can clearly see a huge electrical arc, and the contacts have welded together. That's the purpose of pre-charge. It can instantly burn the internal contacts. If the arc is this severe, they are fused solid. It protects the contactors from damage. That's why pre-charge is extremely important. All new energy vehicles use pre-charge, whether it's domestic brands or Tesla. Even though Tesla doesn't use a traditional pre-charge resistor or relay, it still completes a pre-charge process during power-up. If you want to learn more about new energy vehicle repair, feel free to follow me.